krap. I'm Michael New, and this is Thailand Today. On January 15th, 2022, the South Pacific island nation of Tonga was hit by a devastating underwater volcanic eruption. This caused the deaths of 800 people and displaced 100,000 more. Today, Tonga is still recovering from the effects. What can we learn from what's happened? And could this ever happen to us here in Thailand? Today, we're at Mahidol University's Engineer Studio at the Faculty of Engineering to speak to earthquake and seismic engineer expert, Associate Professor Dr. Thirapan Thamarat. Sawasdee krap.
Sawasdee krap.
Thank you very much for your time today.
Yes, thank you.
Now, the recent volcanic eruption in Tonga is supposed to have been the worst in 30 years. Can you explain how this is measured?
Oh, actually, for this kind of volcanic eruption, we expect it to have like once a year normally for the whole world. But the last one that we saw in Tonga is quite unusual. We did not see that one quite often. So, as a scientist, I would have to say that that's also caught us by surprise also. But the scale of it, some scientists said it would occur like once in 1,000 years.
So once in 1,000-year eruption in terms of scale.
Yeah.
I think I read somewhere that the size of the eruption was equivalent to 1,000 Hiroshima nuclear bombs.
Yeah.
Is that correct?
Yeah. Actually, it also like if you comparing that to the earthquake magnitude, actually, they approximately is about 5.8.
5.8
yes.
from a volcanic eruption. That's enormous.
But if you compare to the one that in Thailand we affect from the earthquake in 2004, that one is 9.2. So you can see that the scale is quite different.
Right.
But
because it's logarithmic as well, so every point up the scale is 10 times more.
Yeah. So it's quite different in the term of the earthquake magnitude also.
Looking at it like that, where the 9.2 earthquake that caused the Indian Ocean tsunami, it's so much bigger. Why was the eruption as dangerous as it was?
Actually, if you want to compare between the earthquake and then the generated tsunami, and then the volcanic that generated tsunami, you have to looking into the size of the area that is actually occurred. For the one that occurred in 2004, the rupture area that have the earthquakes about 1,000 kilometers. So that is quite large.
So a huge fault line.
Yeah, but for the one that we have in 2022, in January, that is just a small area of the volcanic eruption. So we also did not expect it to cause the mass tsunami, but it seemed to be the unusual event that even the scientists also still try to find the answer for that.
You say you didn't expect a tsunami. Why was that?
Actually, because the scale of the volcanic eruption the mountain, we know that when the volcanic eruption occurs, usually it might generate the tsunami, but the scale that it goes through like the Chile or California or Japan, that level we did not expect it because the size of the island is quite small. But now from the recent study, we think that the tsunami that travel across the world that might play with the role of the sonic boom that caused the tsunami also. So it's quite unusual event that we did not see very much.
And this isn't something that you've seen before with volcanic eruptions underwater, or at least not to this extent.
Actually, for the volcanic eruption, we see it quite often, but most of the time it does not cause tsunami.
Right.
And when it does cause tsunami, you would expect it going to be quite local. Like in 2019, we have the volcanic eruption in Indonesia, and it caused the tsunami to the nearby island. That is quite typical one. But for this one, because of the scale of the volcanic eruption and then the sonic boom, and maybe also the size of the volcanic mountain, so when it dropped down, it caused very huge tsunami, and we did not have that one in our database also, so it's very difficult.
So sorry, was it the eruption itself that caused the tsunami, or was it the landslide of moving mass that caused the tsunami afterward?
Actually, for the typical tsunami that causing by the volcanic eruption, it is because the collapsing of the volcanic mountain into the water that causes tsunami. But that one, it is quite a typical one that we're going to expect the local tsunami. But the recent one that we've seen, that is, we see the sonic boom that is come before the volcanic eruption. We think that it might play a part in the way that we see it goes globally. Yeah, so it's the combination of the two.
I see. So it's more about the displacement of water, more so than a shock wave, I think. But possibly the shock wave could play a part in creating some size of tsunami.
From the recent research, they say that the sonic boom might play a part also because of the way that is so strong that we did not expect it quite often. So scientists also quite uneasy to enable to explain it. Yeah, and most of the time we did not have the model or the database for that kind of tsunami. So it caught us by surprising also. Yeah.
Do we have measures in place to predict when this kind of event will happen?
For the Tongka volcanic eruption that caused a tsunami, I need to say that we did not have that often. So the way that we prepare, we did not have the system to predict it. But if it is like the normal earthquake that generates tsunami, I have to say that in Thailand and most of Indian Ocean countries, we do have the system to predict it. So if the earthquake, really the big one that occur, like magnitude 7.5 and it's very shallow, the warning center going to warn the country within 30 minutes, I'm sure. Because we improved a lot since 2004.
Right. As I understand, Thailand does not have any active volcanoes anywhere nearby. So is what happened in Tonga something that we need to worry about in Thailand?
Actually, we knew that in the Andaman Island, we have that in Indian part, there are some volcanic.
Oh, there are some?
Yeah, there are some. But from the recent study, we found that the scale or the activity of those volcanic eruptions is not quite large compared to the Tonga. But the thing is, we more worry is about the mountain range in that part. So we don't know when the landslide going to occur, submarine landslide. So when it occurs, it's quite difficult for us to predict. If when that occurs, if it causes a large landslide,
So these are underwater mountain ranges?
Yeah.
I see. So the real danger is if there is a large landslide underwater, which could cause a tsunami similar to what we saw result from the volcano.
Yes, but I have to say that is not occur very often. So we should not be over excited about it. But if it like caused by normal earthquake and generate tsunami, I think we quite much better than in 2004.
In terms of what we can do moving forward to predict what might happen when this kind of eruption occurs, or possibly to have advance warning, what are we doing?
Actually, we need to understand that in Thailand, the area that we're going to have the tsunami is only in the west coast, that is in the Andaman beach, along the Andaman coastal line. But for the southern Thailand to in the Gulf of Thailand, that area is more safe. More safe in the sense that in the Gulf of Thailand, we have a shallow water. Even though they have a big earthquake occur in Philippines, they're going to cause tsunami. But when it travels to the southern coast of Thailand near the Gulf of Thailand, the level of tsunami is quite low. So that has been proven by the research already.
So the depth of the water plays a significant factor in how big a tsunami can be generated?
Yeah, actually near the shoreline in the Gulf of Thailand is quite shallow. So the chance that the tsunami could come to the southern coast of Thailand near the Gulf of Thailand is very low. But the one that we have problem is only in the west coast. Because in that area the level of the deep ocean is quite deep. So when it comes to that, it's going to amplify the tsunami
I see.
height.
So an earthquake or a landslide would have bigger impact on the western side.
Yeah, but for the west coast, when we have felt the earthquake or there's a warning from the authority, the local people should really try to avoid the beach or go to the safe place that they have been decided. Yeah.
Now, I believe you and your team have prepared a presentation that goes over some of your research into this topic.
Yes.
Could we go take a look?
Yeah, sure.
NBT World, a vision of Thailand.
Welcome back. You're watching Thailand Today. We continue our discussion with Associate Professor Dr. Thirapan Thamarat on the volcanic eruption in Tonga and what we can learn from it. Let's have a look now at the earthquake simulation model. So what can you show us about this model?
Actually, this is the typical model that we usually do in the lab when we want to simulate the volcanic eruption when they have caused the landslide. So you can see that when the landslide occurs, it's going to move the mass, and then you can measure the tidal wave that occur. That one is going to be the tsunami that occur, but you might not see it very clear from here because this is the deep ocean. So in the other part, we're going to have the shallow one, and then when the wave travel through that one, it's going to cause a big tsunami. So this is the kind of the typical experiment that we do to see the landslide and then cause a tsunami.
What's happening to the water at different heights? Is the water at the bottom moving as fast as the water at the top?
Actually, it's the conservation of the energy. So when the water is deep, the energy is going to be dissipated throughout the layer of the water. But when it becomes very shallow, the energy try to convert it back to the same energy, so it goes back to the velocity and then goes back to the height of the tsunami. So when the tsunami wave hit the beach, That's why you can see the amplification of the seismic height and then the velocity also. So it's a conservation of the energy.
That's what you were talking about before, where when you have deeper water, you end up with larger tsunamis.
Yes, normally when we have the earthquake, the one that usually the tsunami warning center going to send a warning that is going to be the magnitude larger than 7.5, and it should be the shallow depth also. So when this combination like 7.5 and then the depth of the earthquake is very shallow, then you're going to expect a bit of tsunami anyway. So after that, the tsunami warning center is going to start to generate the tsunami model. So in this way, you can observe where the tidal wave is going to go, and then you can predict when it's going to reach the coastal line.
So take the Indian Ocean tsunami, for example. After the earthquake occurred, how long did it take for it to reach, we'll say, Thailand?
Well, actually, we have around 1 hour.
An hour. Okay.
An hour. So we're going to have an hour to prepare before the tsunami wave going to hit the coastal area. Then before that, the system, the earthquake and tsunami warning system, going to be able to detect it very fast, like within 5 minutes. And after that, we're going to relay the warning to the public. So it's not more than 15 or 20 minutes.
Okay, so there's still quite a lot of time to evacuate when something like this happens again.
Yeah, but in 2004, during that time in Thailand, we did not expect that kind of tsunami. So the tsunami warning system not exist in Thailand. So that's why when the earthquake occurred, we did not have the system in place in order to warn the public. But right now, we improve a lot. We have a lot of seismic stations all around the country, and we also share the data with other countries. So we are in a better shape if that event occurs again.
We have this system in place now for advanced warning from tsunamis generated by earthquakes. Is there some kind of system that we could develop to give advanced warning for volcanic eruptions underwater? And what would it take to put something like that in place?
Well, actually, that is the kind of the research that not much doing. I would say globally, because even though we know that there is a mountain range in the water, we don't know about the scale, how much it's going to cause the eruption, and then the mass that's going down. So it's quite very difficult area of research that more research should be doing on that in the future.
So we aren't at the point yet where we know what needs to be done to create that system. So there's still a lot of research needs to be performed to look into it and then figure it out from there.
Yeah, but the most important thing is also that when you know that your area is prone to the tsunami, you should not build your house near that area. Like in Japan, when they know that this is the area that you're going to expect a lot of tsunami, in that area they're going to use just for agriculture.
Right.
And then you're going to move your building and city further inside inland. So even it occur without warning, you're going to have less chance that you're going to be hit very hard.
So similar to when Thai people build their houses on stilts, so that when there's floods, then you're outside of the damage zone. It's similar in this case. If you think you live within an area that could be affected by a tsunami, then you should move further inland.
Yeah.
Are there any other strategies that people can do to mitigate the damage from something like this?
Actually, what we should do is that we prepare for the tsunami evacuation route. Like if you're going to living in that area, you're going to know that where is the safe zone. So when the warning really occur, you can go to the evacuation shelter very fast, and then that would require a lot of strategic involvement. Like is this evacuation route safe enough for everybody? This evacuation shelter is enough for everybody in this area? And actually, they need a lot of strategic study before it becomes the policy. Yeah, but I think this one we still need further research on that also in the coastal of Thailand.
Now, if I may ask, what is this machine here?
Oh, this machine is like the machine that we going to detect the earthquake.
Okay. How does it work?
So actually this one is very sensitive. So actually inside there is a sensor, and then when there is some triggering, the machine can record it, and the machine going to connect through the system, and then it's going to interpret the vibration into the earthquake magnitude. So when the earthquake occur, and then we can detect it from many stations, not just one station, like 100 stations at the same time, and then they're going to determine the earthquake magnitude. Then they're going to tell us that how reliable the result.
I see. So that's kind of like triangulation on a much bigger scale, so you can pinpoint the exact location and the exact magnitude of the earthquake.
We use this kind of machine to warning the public. Actually, we have this one in our university to do the research also. Like when the shaking occur to the nearby building, we're going to measure the damage it might cause to the building.
Do we occasionally get earthquakes in Thailand?
Actually, we have the deadly earthquake in Thailand in 2014. That time we have like 2 or 3 casualties in the northern part of Thailand. That one was 6.3 earthquake.
6.3.
Yeah. So it not occur that much often, but when it occur, it cause the damage. So we should build the building better also, following the regulation, because most of the time that we observe from the damage from that earthquake, most of the collapsed building is the non-engineered building.
Right.
That's going to collapse easily anyway.
So I see. So similar to Japan, where many of the buildings are engineered to withstand earthquakes, what are some engineering solutions for buildings to withstand earthquakes?
Actually, from the damage that we observed from the northern Thailand earthquake in 2014, what we observe is that when you build the building according to engineering standard, you're going to expect less damage. Just follow the engineering standard, you're going to expect less damage. But if you're going to build a building not following the engineering standard,
that was the problem. So if you build something not to code, then it could be very weak in certain areas or be liable to collapse.
Yeah, in the one that we observed in that earthquake, we observed that when the building, like some of the building, the building column doesn't have even the steel, just the concrete. So it's going to collapse very easily. So that is what we observed, and that is the learning point from us from that earthquake.
So in terms of early prediction for volcanic eruptions, we're not quite there yet, but that's what you guys are putting research into, and hopefully other universities are looking into this same fact. However, as you mentioned before, there are many things that we can do to mitigate if we know that we live in an area that could be affected by an earthquake or a tsunami. Professor, thank you so much for your time today. I really appreciate it.
Thank you.
And there you have it. From Mahidol University's Associate Professor, Dr. Thirapan Thamarat, on lessons learned from the Tonga volcanic eruption and how we can better prepare ourselves for future disasters. That's it for our show today. We broadcast every Friday at 11 p.m. on NBT2 HD and every Saturday at 9:30 p.m. on NBT World, as well as live on our NBT World YouTube channel. Don't forget to like and comment on our Facebook page, Thailand Today Online. I'm Michael New. สวัสดีครับ